So you guys can see my screen?
Yep.
Okay, great. Let me rearrange the windows a little bit. Okay, so I added 2 more examples for our GitHub. So the address is the same as yesterday. You can just fetch this code, which is the latest version, like 10 hours ago update. So you can go to the scene folder, and we have 2 more sort of example here. The one is the water temperature. I a little bit expanded the REST API example for you guys. So I create a plane here, and then import the pixelated world map just like this, and then I attach as a map to the plane, right? And if you go to the main object, it has a script which allows us to fetch like a multiple place throughout the globe, and then we visualize it as a cylinder. This is the goal. Same as before, we have an API key. Please use your API key because it has a limitation, right? And I explicitly mentioned the name of a major city on the globe. Yeah, you can actually add as you need as the name for fetch the weather data. Then for the first loop, I want to just explicitly get the information first, and then add the individual weather information into weather list, yeah, which is list here. So the reason I declare this variable on the level of this class is because throughout the function, like start and update and other function inside of the class, we can access the list of the data. So for the first loop, yeah, again, based on this name of a city, we're gonna fetch the weather data and then save them in the list. For the second loop, based on the data, we are going to create the cylinder and then update the position. Yeah, vector, update the position here. But the only difference between this example and the example yesterday we visit is we have some special color, the function to create the false color mapping stuff. So I will talk a little bit about later. And then other than that, everything is the same. Also, every 100 frame, we are going to update the weather data. So click the play button. You can see the visualization, as you can see here. So northern hemisphere, so we have like a more high temperature. It makes sense. So the interesting thing is that I opened the 2 parameter by putting public keyword, just like that. Once you put the public keyword, we are able to access from the inspector in the Unity here. So this is the remap functions here. So let me click the one of the highest temperature here. It's 29 in New York, right? So in this case, I can click the main. The max remap is 40, so I'm gonna put the 29, maybe 30. So this maximum value is 30, and the minimum value, what is the minimum value here? Maybe Cape Town, 11, maybe you can put the 10. So that we basically create the right sort of range, yeah, by applying the remap function, because the temperature is always fluctuation. So actually, you know what? This could be as a homework to you guys. So since we already fetch all the weather data first, and then we can make the other for loop, right? In order to calculate the minimum temperature and maximum temperature of this collected data, so that we are able to know the exact minimum and maximum data, the number of these data sets, rather than play with this number. Yeah, but also you can play with this parameter to regulate the min-max remap things. So just for your information, I guess we have a data set just like here. So maybe mean is, let's say 0, and then maximum is number 1, maybe 1.0, f, which is floating number. So this is our target, so normalized value, right? But however, the temperature, we have no idea which one is the minimum and the maximum. Sometimes 40 Celsius or minus 10, maybe. We have no idea. So that's why we need to remap, because the false color is usually, let's say, false color is a color gradation for map visualizing data, particularly for false color simulation. So Ladybug's Honeybee and other simulation tool, they use the false color to visualize the number. So in this case, I don't know, minimum is 0, but 800 is like a maximum, I guess. But we need to remap to visualizing the color technically. So in that we have another false color, for example, and it has its own sort of min value and max value. So we need to remap this value between 0 and 1. So this is the function which allows us to remap. So here, the C value is the value that you wanted to remap, and then all the minimum and maximum is the number from this data, yeah, potentially, right? And then new minimum and maximum gonna be 0 and 1 because the false color, the function that I provided with for you is they need to normalize value between 0 and 1. So that's why I need to remap just like that. So I think this is only special things that need to be just explanation. Okay, so let's go to the other example. So I apply, yeah, go ahead, Bianna.
I was wondering if you guys have any questions about that, because basically that example is, would you mind going back to that? It's kind of it's principle of any graphing, right? So using axes for mapping is a very in a two-dimensional way is pretty much information visualization 101, where you're using height as a way of showing variation. However, in this case, we're spatializing the information, right? So we're placing it on the city. So I'm sure you've seen many maps like this, but what's exciting about this is the fact that obviously this is real time, right? So the fact that it's not oscillating up and down, it's basically the database issue, right? It's not a visualization issue. So there's ways that, and this is again, this could be a fun thing to try. If you introduce some randomness, or if you connect to another database that's oscillating faster, right? Updating faster. So you would have these pipes that are going up and down. But basically, this visualization here is kind of fundamental of information visualization when it comes to not only place it spatially, but also temporally, right? Thanks.
Yeah, thank you for additional note. Great. So if you guys have no question, let us jump to other example. So this is the identical example as before, but we have different projection because previously we used, actually there's no projection, but it looks like a Mercator projection, which we unlap the spherical globe into the two-dimensional plane. But in this case, we use sort of a spherical projection. So the question is how we remap, the latitude and longitude into the spherical the position. So if you click the play button, then you can see some sphere which representing the temperature. So if you click the main button here, again, we can remap the minimum and the maximum. Yeah. And also we have a scale factor so that we are able to see the more clearly between the difference for the temperature. So, and also the other thing is that I populate the sphere and then I attach to the globe. So that if I rotate the globe, the rest of them follow the rotation of the globe because they have children-parent relationship. Let's go to the code. The same as before, but we have this projection. This one line of code is important. So before we talk, I will describe something to you guys. So usually the latitude, the geographical position, we use the two numbers, right? Latitude and longitude. Latitude is usually talks about sort of the x-axis in the Cartesian coordinate system. And the latitude, this is the longitude, and the latitude is you can use along the y-axis. And however, the starting point is a 0.0, right? And then we can go that direction to 180 plus, and this is minus 180 direction. And we also have a 90, go the positive direction, and minus 90 is a negative direction, right? So we need to remap that one is as a sort of a spherical position. Yeah, this is a scene. So basically, just we have a paper, and then you can wrap the paper as a sphere, so that we have this kind of the theme here. So maybe okay. So this we can attach this line to here, and then in the wrapping up, so that let me draw a circle. Just like that. So this gonna be attached to that direction. That one is that direction, right? So this seam is the place where these two edges are gonna meet, right? So these are the important concept to understand how we calculate this latitude and longitude position into this spherical projection. So here, first of all, we need to remap the longitude. If you press Control and mouse left button, and we can go to that the function. So this longitude could be starting minus 180 here, right? So that's why we need to apply. We need to add 180, right? So that we can make them as the minimum number is 0, right? And also this is the full circle, like a 180 plus 180 gonna be 360, right? So that we wanted to apply the pi. Pi is indicating the full circle for the degree, so that we can apply this kind of the mathematical equation. And if vice versa, we can also need to massage the latitude number using this sort of function. And this is the simple mathematical equation to convert x and y position into the spherical things. And the important thing is that the coordinate system in Unity is a little bit different than other CAD systems that we are familiar with. So we need to apply basically swap between y and the z axis. Yeah, this is the key that you need to understand. And then now we get the correct vector, and then apply this vector for the position of the sphere that we just create. And then same as before, we apply the color with this normalized, the false color based on the normalized value, which we apply the remap here. So that's why we are able to see, the same data as we did. Then we can see Cape Town, can click it, 6 Celsius, and then we can click the LA. Yeah, it's Mumbai. Oh yeah, it's Mumbai. It's pretty hot, right? And then click the New York. New York is also pretty hot. We can rescale a little bit to see the position. Yeah. So, any question about this example? Yeah, I mean, in this example, what I wanted to talk is that the latitude and longitude is the absolute important value to indicating the position, right? I mean, the GIS is the only difference. The important difference between the data and GIS is position. Location is really important. So that throughout the latitude and longitude, we are able to mark or save the data into particular position, right? But I mean, the place is a kind of relationship between their neighborhood, right? So that there's a lot of different types of projection to visualizing the geographical information. So I think the understanding projection is an important way of the understanding relationship between place and place throughout the globe. So yeah, if there's no question, then I can stop my screen sharing. Yeah, you're mute.
Yeah, sorry. So we want you to spend some time exploring these because unless you have a lot of experience with, let's say, working with longitude and latitude, and so if you could take some time and why don't you explore different cities, or add a city, remove a city, and see how the example changes.
Okay.
Again, this takes the previous example, which is spatial and temporal mapping, and it's basically taking the visualization one step further, right? So although we're all familiar with planar maps, but once you're able to not only map it over a sphere, but you're also applying rotation, in this case, you're also considering the point of view of the observer, right? Because it's clearly much easier to look at the information all at once on a planar map. However, what is missing is more of the engagement with the topic, right? So once you are mapping this over a globe and this is spinning, we're also starting to understand other nuances about the environmental issues. So for instance, when you're looking at all information in a planar way, they're starting to have a spatially much more different relationship. You're starting to notice perhaps their concentration more, whether they're more concentrated, let's say, in different zones. However, when you're starting to map, you're starting to see adjacencies in a very different way, right? So all of these could be used as an intention for you when you're looking at information visualization. So what about, we've seen this quite a lot. Sometimes you enter a museum and there's a globe hanging and it shows you the information. What about typical information visualization that is using planar projection? And NJ talked about the Mercator projection, which is one of the most, I would say, one of the oldest projections. But you're probably aware that there's many different projections, right? So all of these projections, they have a way of skewing the geometry, and there's incredible videos and examples of how basically by emphasizing one projection plane over the other, you're also changing the focus of the data, right? Yep. So yeah, go ahead.
Yeah, I mean, this is the Mercator projection. So in this case, we are able to preserve the angle, as you can see the grid. But however, we need to give up preserve the area, as you can see. the one grid has identical to each other. But if you go to the north and the south, then the box is gonna be elongated, right? So meaning that we are losing sort of precision of the area. However, so in this projection, so we are able to preserve this kind of the area to each grid it can have. However, the angle of the direction we're gonna lose it. So I think individual projection has their own sort of purpose to visualizing and emphasizing something. So for example, like if you just think about it, if you're visualizing some data in the United States, which projections are you going to use it? So based on the projections to the United States, position of the United States and shape of the United States is gonna be a little bit exaggerated. So just think about it. If you have a right latitude and longitude, no matter what, we can project this point or visualization shape on the United States. But while the projection is changing, this the relationship between the points and then visualization on the map gonna be a little bit different. Because the reason we wanted to have the mapping is because, as I mentioned yesterday, human being is a visual animal. So we need to sort of mine some visual relationships throughout the mapping. So in this context, projection is a really important things before you try to map. I mean, based on your data, you need to understand which projection gonna emphasize your intention of a visualization, so that maybe you can use multiple sort of projection, then you can compare the different types of visualization in different contexts. So this is also one possible way. I think this is also interesting things. I mean, if you visualizing the macular, the red line is the macular projection. And then the green line is the projected latitude and longitude, and the Lambert composite conic projection is the blue. If you remember, like the visualization for the United States, like a president vote system, and then they always use this conic visualization. So what I'm saying is the conic visualization is maybe suitable or fit for the United States map, for example. So projection is the things you need to consider before you visualize it on the globe. Yeah. Any questions about the two additional examples? Great. And also I have found something interesting for the projection. Could I share my screen for real quick?
Yes. Go ahead.
Great. This is one of the famous visualization library for the JavaScript. So as you can see here, we have different types of pre-built projection. Yeah. So yeah, there are multiple projections. This is the projection that we discussed for the United States, and other projections available. This is macular projection here. So I implement this kind of example in the on my sort of sandbox. So my mouse position is indicating the red dot, and then the green dot is actually the projected value here. So you can pan and drag, and then we can actually play with some projection just like that. Yeah. So maybe you can emphasize some particular area or de-emphasize, or I mean, based on your density over your position, you can pick which projection is better for describing your data. Also, if you double click it, we can change the other projection just like that. Double click, keep changing the different types of projection. This is a spherical projection here. So yeah, I mean, this is the idea behind the scene, how we sort of understand and take advantage of the projection when it comes to visualizing your data on the map.
Okay. Were you guys able to download the render doc, Blender, ready to go?